Yet if, as I hope, basic science becomes part of general awareness, what now appear as the paradoxes of quantum theory will seem as just common sense to our children's children.
Yeah, so he was an outlier's outlier, and he lived nearly 60 years with his condition, and obviously made a great contribution to science. In that time, most people live between 2 and 3 years from diagnosis, so they have a much shorter space, and their disability changes very dramatically. Why does this happen? We would love to know, because it might give us an opportunity to try and enhance those processes in terms of therapy. I think it's very likely that there were a variety of genetic variants in him that made him protected in some way, that meant the disease course was slower. So motor neuron disease is a condition in which the nerves supplying muscles in the brain and spinal cord degenerate, and the muscles become either profoundly weak or very stiff, or a combination of both. And that means you can't do the things we normally do every day: walking, talking, using our hands. There's a protein in particular that's accumulating within the cells that we believe to be toxic. We know a large number of genes can contribute to that accumulation. We don't yet know how it ends up poisoning the motor neurons itself. We also need to figure out how to clear it. So you can see here, these are dendrites. These are the connections between neurons, how they talk to each other. And the little tiny hairs on these, they look like hairs, little pouches, they are the connections between nerve cells. So that's how cells communicate with each other. And what we know about motor neuron disease and many other degenerative diseases of the brain is that these little connections are lost. So you tend to lose those tiny little spiny processes. Younger people tend to survive longer. Males tend to survive longer than females. But equally, there are some people who get very aggressive disease at any age. So Stephen provided DNA for analysis, and we have sequenced his genome. That is part of a really huge project involving nearly 14,000 people's genomes that we're sequencing. And obviously we're very interested in him and others who lived a long time to see what variants they had that might be protecting them. If we could switch those variants on in people, that might be a therapy. So that's a very exciting and important area.